Hi everyone, great to be here. I'm Tim, as mentioned. Cool to be here in Chicago, never been here, first time, so awesome. I'm here to talk about monitoring as code and then very specifically how you do that with Playwright. You could also call it end-to-end testing in production. What we're going to talk about incorporates elements of end-to-end testing, QA, browser automation, DevOps, and general software engineering. A little bit of foreshadowing what we're going to talk about. At the end of this talk, I hope you kind of find out that testing in production is a good thing. It's not only a meme. That you should be doing this as code, this testing in production, rather sooner than later. And that monitoring as code is kind of DevOps in its purest form. We'll get to that in the end. Cool. Great. A little bit about me, very quick. I'm from the Netherlands, so excuse my accent. I studied computer sciences back in the 90s. I also studied art history, which kind of makes me a little bit of a split brain between technical stuff and, let's say, aesthetic stuff. Used to work, again, in the late 90s, early 2000s, lots of IBM, Java, G2E, Java applets in Internet Explorer 3 stuff. That was a ton of fun. And mostly working on Node.js, TypeScript, and cloud and startups. I'm one of the founders over at Checkly. If you want to know more about that, come up to me later. That's about me. Let's dive into the actual meat. The problem that we're going to talk about. So, what is this problem? Let's go back 15 years. This was the cloud-native landscape. It was simple. Life was simple. We had a bunch of servers, then we installed some apps on that. The servers were connected to the network. Boom, you're done. That was it. That was my life for at least 10 years. Sometimes when things got a little bit more complicated, we would have multiple servers. And that was really a big thing. We would put a load balancer in front of it, and everything worked fine. Then we got the cloud explosion. Big data, web scale, cloud, Kubernetes, serverless data lakes, streaming, mesh networks, distributed system, blockchain, open telemetry, cloud native. Amazing. Everyone loves it, of course. This kind of makes things a little bit more difficult. And I'm not, slamming this. There were very, very, very good reasons for why all this technology got invented. But I also kind of love about this image always that there's like SAP and Oracle on it. It's kind of cool. Then we got microservices. I don't know if you've seen this video. If Omega Store got their shit together, everything works fine. So we had the same stuff actually for the front-end technology, right? So we used to just write HTML. And now we get, what did I write down? Angular, React, 700 other front-end frameworks, mobile, CSS and JavaScript, single-page applications. Cool. So how do we keep track of all of that? That turns out to be actually a pretty hard problem. And because all these apps generate a ton of data. And I'm talking about monitoring data, logs, metrics, traces, quite a lot of stuff. So that gets, large volume, and we invented something for that. We rebranded monitoring to observability. So we got a whole new industry for that. That's great. And we also introduced a new concept, and that's paying a lot of money for that, as in a lot of money. Mostly more than your actually infrastructure bill, right? So that is kind of a thing. And I don't know about you guys or the organization that you work in. We've noticed that people don't, it gets a little bit annoying. So being an art history major, I came up with this analog yesterday night. Observability is like a Jackson Pollock. It's very noisy and it's very expensive. Cool. So how do we get a clear signal about this? And what do we mean with a clear signal? Well, let's ask this question. Does my app still work? Does my app still work? I'm paying Datadog 60 trillion euros per day for a whole bunch of data. Does my app still work? So a bunch of words here that are doing some heavy lifting. What do I mean with app? I'm just trying to make it a little bit more simple. I mean a web application, an API, any service that you're running. Might be on the internet, might be internal, might be machine to machine, it doesn't really matter. Is it still working? As in, is it working now? Is it going to be working 1 minute from now or 1 week from now? And with work, I mean, does it provide the expected business function correctly and timely? Again, this could be anything. It could be booking a flight ticket. It could be one API or one service calling an API for a bunch of data. That's it. And does it work for the end user, customer, or the machine on the other end of the line? And then the last, does it work in production, right? It doesn't work in, your unit test or some end-to-end test you might run in CI/CD. Does it work in production? So yeah, that's a whole bunch of heavy lifting going on there, but we're going to get back to this question quite a bit. Does my app still work? Cool. So you might think, well, don't we have QA for that? Or like automated testing? They should solve this, right? That's kind of what QA is, or monitoring in general. Yes, we do actually. And again, once you have QA practices, you know that if you cover everything in unit tests, every function on a CI run, you cover all your business flows with end-to-end tests, and of course you do that up to roughly 100% code coverage, as everyone does, then you can be 100% sure that once you go to production, everything still works. Everyone knows this, right? So I'm being a little bit facetious here. Of course, this is not how it works. And I'm not dunking again on QA or automated testing here. You should all keep doing that. It's a very good reason to run unit tests. It's a very good reason to do end-to-end testing, whether that's on an API or a front-end web in the browser, it doesn't really matter. I'm actually arguing the opposite. We should learn from QA and automated testing for production. But this, again, poses a bunch of questions. Why does the typical QA cycle stop at production? We do all this work to do, we have people do manual testing, right? Automated testing, and once it goes live, we're calling it monitoring. It's something completely different. Different team does it, different tools, completely different system. These people don't even talk to each other. We start calling it monitoring or synthetic monitoring. That's the product we sell. Uptime checks, ping checks, all kinds of different terms for it. But they're also always associated with production. Before production, it's called QA or testing. Why do we have that context shift, right? Why is testing in production essentially a meme and everyone kind of giggles when you talk about that? Couple of problems there. And we're going to break it down roughly into these three. I just came up with this last night, so don't pin me on it here. We have a tooling problem, we have an architecture problem, we have a culture problem. We're going to go through them. We're going to start with tooling, because that was also in the title of this talk. Enter Playwright. So, what is Playwright? Playwright is a browser automation framework, and it looks like this. I hope you can read TypeScript or JavaScript. It comes in different flavors, by the way. And Playwright automates interactions in a browser, but it can also do that for just straight HTTP calls. So you can also test your API with that. Remember that. Most of it is focused on browser stuff, but it works really well for API, and I'm going to give you some demos there. Let's go through this code example first, because there's quite some stuff actually going on here in these handful of lines. I hope it's readable. So what do? Well, we import the Playwright test function and the expect function. We open a test function, which gets a page injected. We're going to talk about what that is later. We call a function on the page object, which says GOTO, in this case, GOTO Chicago /2024. Cool, it does that, opens up a browser, spins that up for you. And then we're going to look for a link with the name, or actually the text, called register today. There's a bunch of them on this page of GOTO Chicago 2024. We're going to pick the first one. That's the little first function. Then we're going to click on that. Then stuff happens. There's a navigation that happens. And then we're going to do an expect. This is an assertion, essentially, that says, hey, grab me a heading that has the name register and make sure that it's there, that it's visible. There's a whole bunch of magic going on here. First of all, notice that the get by role function, we're not using any CSS, right? It's just a link that has this text in it. Some of you might be familiar with other frameworks. You would have to do CSS selectors. If you're using any front-end framework that's a little bit new, these are all, gobbledygook. They're random strings, so that doesn't work anymore. So you put in IDs, okay, then you change the ID, okay, and it all breaks. These are kind of web-first locators. Same happens in the expect. These are web-first assertions. So what does that do under the hood? Well, it's going to search through your page, get a role by heading. Notice that we're not naming it a DOM element. There's no such thing as a heading. This is a web-first locator. It's going to wait till it's visible. It's going to wait till it's loaded. Then it's going to make sure that it's visible. What does visible mean in a DOM context, right? It could be some pop-up that comes up, a cookie banner. That means it's not visible. So visible is not the same. It is part of the DOM, or it has been rendered. So there's a whole bunch of heavy lifting there. It could also be that this element was animated, and it flies in from the side. It's going to wait for that, for it to be visually visible. Let's say this doesn't work. What Playwright does for you, it's going to retry that up till a certain timeout. And we don't need to do anything for that. So it's pretty damn smart. Cool. So that's the code example. A little bit of background on Playwright. Playwright is kind of like the latest and greatest in browser automation. Some of you might know some of these names here. Selenium has been around for quite a while. Two of my co-founders worked at Sauce Labs, big Selenium shop. They know everything about it. They never want to work with it again, because now we're working with Playwright. Phantom.js, funny story. The first version of the product that we built was running on Phantom.js. But then Puppeteer came out. Puppeteer is kind of Playwright's, let's say, ancestor. That was built by Google. It was the first browser automation tool that really took it to the next level. The team building Puppeteer at Google moved to Microsoft, and they're building Playwright right now. I don't know what drama happened there, but Google is Google, you can guess, right? So there's also Cypress there. It's been around quite a while also. Pretty similar to Playwright, different execution model. Cypress runs in your browser, literally. Playwright is essentially a node process. It runs on the back end and communicates with your browser through the DevTools protocol. That's the history. Why Playwright? Playwright is also fast. We did a speed comparison test like a year ago, where we put Cypress and Selenium, Playwright, and Puppeteer, and you can consistently see that Puppeteer and Playwright, because they share this heritage, are way faster. This compounds when you're running this in CI. It's gonna, save you hours, days, weeks of time of waiting for tests to pass. Playwright is also popular. Little chart from NPM where all the Node.js packages are downloaded. You can see that recently Playwright surpassed Cypress in downloads. So there's a ton of momentum there, which is, cool, but it's in real life it also helps. There's bug fixes, there's good tutorials, there's blog posts, there's videos. People are jumping on this platform quite heavily, and that helps. Good. Where are we here? Okay. What do you get in the box? So let's say you install Playwright. It's npm install Playwright, kind of how you install any package. You get the browser automation part, you get the test runner part, which I'm going to show you later. You get a debugger, and you get a recorder. The recorder is pretty cool. I'm not going to show it today. It's called CodeGen. You do Playwright CodeGen. It opens up a browser, and then you start clicking around, and then you close it, and it has a piece of code for you that recorded what you just did. 80% of the time, it's pretty good. Sometimes you need to tweak it a little bit, but it does get you started really, really, really quickly. As mentioned, it does this web-first locators and assertions, and auto awaits a whole bunch of stuff. So if you want to click on a button, in other frameworks, you have to okay, now wait for the button to appear. Now click it. If the button doesn't appear, retry it. This is all taken care of under the hood. It's pretty damn good. So less flaky tests and less flaky monitors. I'm going to show you the TypeScript and JavaScript version, but they have language bindings for Python, Java, and .NET. They're typically a little bit behind because Playwright itself is written in TypeScript. So that's kind of the first one that rolls out of the factory over at Microsoft. What's also extremely cool, and I'm definitely going to show you that, the moment you run this, you get a bunch of traces. These are essentially DOM snapshots where you can do time travel and look at, okay, something broke. Why did it break? You might have a test that goes through a couple of steps, might be 20 to 30 seconds long. In the middle, something happens. What went wrong? Going to show you that. You get videos, also pretty cool, sometimes really easy for super quick, like, okay, what just happened? And you can take screenshots in all kinds of ways. Super nice. Can automate Chromium, WebKit, Firefox, and Edge. And with a little tweak, you can also have it run on Chrome, not Chromium, although the differences are pretty slim. All right, let's look at some code. Let's hope it all works as designed. I made a little project here, and I'm definitely going to blow that up a little. Let's see, here we go. Yep, a little bit too big. Okay, this is a little Playwright script. It's fairly similar to what you just saw, just not targeting the GoToConf. Oh, it is actually the GoToConf test. So let's just run it. Let's see what happens. Boom, and I'm going to run it. Put a couple of things on. Can I get rid of this? I'm not a VS Code user normally. Yeah, no. Okay, you're just going to have to believe me. There's a command at the bottom here. Hope you can see this. I'm running npx playwright test, and I'm going to make it headed. That's the flag I'm setting. And I'm just going to do that for demo purposes, because then you're going to see the browser pop up. By default, it's headless, nothing visible. And I'm turning the trace on. Normally, you don't really do that, because if the test passes, you're not interested in the trace. So there's a little handy thing there that it only traces on first retry. But for demo purposes, this is pretty cool. So let's see what happens. Go. Our website. Register today. Boom. That was it. Pretty quick, because it's not, as slow as a user. It will then poop out a little command if you want to look at the built-in report. And just a simple HTML page, which kind of shows you all the things that you're interested in. All the test steps are rendered here. You can kind of dive into that. Okay, cool. But let's say this has failed. Then you have the trace viewer. This is kind of extremely useful. This is the time travel debugger. And you can see, okay, browser gets opened, page is loading, slowly. Okay, everything's there, amazing. Oh, and a navigation, cool, everything's there. At each step, we can also inspect what happened in the console. In this case, no errors. Good job, GoTo. We can look at all the network interaction. It's just like opening up your browser, right, and the DevTools. If something is broken here, you're pretty quick at finding out what actually happened. There's before and after states, a whole bunch of stuff that's extremely useful. Then let's close this or move back. And of course, as promised, it's just an MP4 that's going to render the thing. Could be useful to send to someone that you don't want to give access to all the traffic and all the nitty-gritties, maybe for internal apps, but you do want to have them visualize or show them what actually happened in this test run in this case. Okay, this is like the simplest thing you can do. Let's look at another one. We have, at Checkly, we build a test target, and it's called the Danube web shop. Danube is, I literally thought for a year that it was like, if you're a noob, but it's like Amazon, but then Danube, the other river. Took me a while to figure out. It's also a bookshop. It's a super simple app that we cannot really break because we use it as a testing target. So what are we going to do? We're going to order a book on our account. We're going to log in, we're going to click on a book, and we're going to put it in the shopping cart. You can imagine that for a typical e-commerce shop, this is like critical that that works. If that doesn't work, you don't have a business. Okay, Let's figure that out. So what you see here is a script that does exactly that. A couple of extra things that we want to see here. We're going to fill in the username and the password. In this case, I just put in plain text in there because it's all static. You would typically replace that with an environment variable because you don't want to leak those secrets. We're going to click on sign in, and then we're going to go see that there's actually a welcome message. Okay, let's do that first. Cool, I'm going to do exactly the same thing. And I'm just going to change which script we're running. I'm going to make it headed again so we can see what's happening. Boom, log in, done. Pretty quick. Good. I actually noticed that I removed the adding of the book because the thing would be too big and you couldn't see it on the screen. Okay, this makes sense, right? Oh yeah, we actually moved it to the other test. Good. So, let's say you work at Amazon or a large e-commerce provider. You have 700 teams building against, the common platform. They all want to write tests. They all need to go through this login stage. Okay, are you going to ask 700 developers to kind of, code that themselves and, deal with all the complexity there, put in their credentials? Probably not. You want to dry that up and get the login code in a library that everyone can just call and it just stays the same. And then devs can focus on, hey, I'm working on the accounting, I'm working on the book section, I'm working on the movie section, stuff like that. One of the super, super, super powerful things that come with Playwright are not strictly speaking Playwright specific, but really well implemented, are fixtures and page object models. Look at this, what's happening here. We pass in this page. Page is a standard object created by Playwright. It just doesn't have a concept of where we're going. It just has a blank. It's kind of matching to a tab in your browser. But now we have a logged in page. That's one of our own. How does that work? Well, we have to do a couple of magic things in the Playwright config file. There's a ton of options there. We're not going to go into them. But there's a bunch of things that are interesting. So we want to actually have a way to, I'm actually going a little bit too fast. We want to have a way to dry up that, authentication step. Okay, what do? We go to this little puppy here. We make our own class that extends page and it does the login for you. And then we export that into its own thing. It's just TypeScript. Nothing here is very specifically Playwright because we're just extending that and we're putting in our own logic. So now that I've done that, I could put this in a library and ship that to my users, and then which could be other devs. And they can start using this one instead of the other one, where the logged in state is baked in. Super cool. Let's just run that. And we're going to now actually make sure that there is a book there. Great. Oops, I screwed it up. Okay, you just saw the login happen again, right? This is just because that code is now essentially inserted above the script that we already had. Okay, that's great. So we dried up that logic. No one has to think about that anymore. Now we want to run 600 of these in parallel. Okay. So we're going to have 600 scripts logging in, logging in, logging in, logging in, and then doing their logic that's specific to that test. Sounds not great, right? Because your authentication provider, we use a third party, is going to flag like rate limit, bots, stuff is going on. It's bad. So we can extend what we just did, this drying up the login, to what is called storage state. And this is pretty fancy. And I just put two tests that kind of do exactly the same here. And we're now going to actually log into Checkly. This is a real test. I super hope it works, by the way. Tested it this morning. We need to just do one little thing there. The authentication logic that I just showed you, and that's where this comes in, put this in a separate file, and I create in Playwright essentially what's kind of a mini CI process where I say, okay, I have my normal tests. They run on Chromium. That's the project you see in the middle. But this project depends on setup, which is the project before that. The project before that will log in grab a bunch of cookies, store that in a specific file, and then we're calling it user.json, which you can see there. And now all the other tests that run after that can use those authentication credentials. This makes it way easier to parallelize all of this and just log in once and start reusing those credentials. Okay, let's see if this works. I really hope. And now we're actually going to log into an actual app, our own web app. Yep, that is my test user. Yep, cool. Now it's done. And now we're running 2 tests in parallel, going to Checkly, boom, done. It worked. You can imagine that this is extremely helpful in cases where you want to do some more difficult stuff behind a login. All right, cool. I promise you to also show you some of the API stuff that Playwright can do. It looks very similar to what we just saw. In this case, we're using the public API from SpaceX. Note there where we start a test that we're not importing a page, but we're importing a request. No browser involved here. And what we're doing is we're just, doing HTTP requests. We're saving the responses that come back, and then we're using those responses to do another request. In this case, we're going to grab all Dragons capsules, poops out a whole list of them. Then we want to grab one of those from the list. You can see here first we're exporting this variable, then we go there, we're going to wait that it's there, and then we want to have some kind of expectation that the names match up. And then there's a last step. This typically mirrors a user journey that you would have on your API, right? You don't only have user journeys and clicking on web stuff. People go, get a token, they poop out a list of things, they grab the third item, they update it, they might delete something. This is a typical use case. Works pretty much the same. I can do this, run it. The headed part is not going to do anything interesting because there's no browser. Trace is also actually not going to be doing anything interesting. So we're just going to run it. And you'll see that it's actually pretty fast. Oh, I left the authentication step in there. I should actually not do that. In this case, it doesn't hurt. It did the thing. If this would fail, you would still get all the logging right there. Okay, so I hope you get kind of a, how do you say? Kind of a good overview of what you can do with Playwright. Then I will just re-emphasize that what we just saw, these fixtures, the logged in page and the page, plus page object models, which are abstractions that you kind of do, like logged in page, go there, plus this storage state is super, super, super powerful. We have quite some companies using our product, more than 1,000, some large ones. All of them end up using this because they're all bumping into exactly the same issues. Some of them are like, oh, we don't need that, we're going to solve it by ourselves. No, you're probably going to want to use this earlier than later. Put some time into it, abstract some of the reusable logic, and your life is sweet. Great. Gotchas. You start using Playwright, maybe just for testing, totally fine. 100%, maybe 99% guarantee you will bump into this. First of all, your browser cache is always empty. Kind of annoying, because you're used to, I don't know, I read Hacker News, it's always logged in. You go to Hacker News and then, oh shit, yeah, I need to log in first, because there's no caching of your credentials or anything. It's also going to be a little bit slower always, because all the images need to be downloaded, all the assets. Okay. Anything login or authentication can be tricky. There can be redirects, there can be bot detection, there can be rate limits, can be a little bit tricky with Playwright. It's as easy as it gets, let's put it this way. Browsers, they hog memory and CPU. You can run this in GitHub Actions, a ton of people do that, or in any other CI/CD system. Bring some larger machines if you want to run a whole bunch of these in parallel, because a couple of 100 megabytes per browser tab is not uncommon. Then your HTML structure that you're going to be dealing with will suck badly in a lot of cases. So all of those fancy Playwright things, web first assertions, gets a little bit tricky, and you might have to fall back to this specific CSS selector that marks a link as an H1, well, it's not really an H1, all that kind of stuff, right? Yeah, people are, are not always the neatest. You'll see that if you stick to good HTML structure, everything becomes a ton easier. Great. Let's see where we are. These were the gotchas. Then we're going to move into monitoring as code. Because we talked about some problems, right? The problems were first tooling. I think Playwright is a very good tool to use for all of the problems we're going to encounter. But we have an architectural problem also, and that's this. Production is not pre-production or user acceptance testing or staging or test or whatever name you have for it. All those environments that you might be used to run your tests on are not production. And we have to recognize that. Just some simple things. The data, it's going to be different, I hope. You don't have your production data on your test systems. So it's going to be larger or in a different shape, or you can't even access it because you're, I don't know, you're in the military or you're a bank and it's very protected. Security again. You might have all kinds of bot detection there that are very specifically only running on production. Are you running Cloudflare DDoS protection? Oh, if you fire off 600 checks with a bunch of essentially bots, that's going to go off. Lots of our customers have had this problem. Luckily, we're whitelisted now at Cloudflare that we're a good bot, but yeah, sometimes painful. Third-party services and dependencies, super cool. Do you have a LinkedIn tracking pixel or something else going on only for production? God forbid you have Google Tag Manager where teams insert random stuff in your production app. It can screw everything up badly. Scale. Mostly your production system is way larger than your test system. Sometimes that's a good thing, sometimes that's a bad thing, Geographic distribution. Large apps run all over the world. Are you taking care of that? Are you taking care of, or are you only testing the version of your app that runs in US East and the one that's in Australia be damned, right? With testing, you don't have that. You test normally against one system that's accepted, that's fine. Okay, so how do we solve that? This is the sponsored section, explicitly the sponsored section, because we bumped into this problem quite early on. And I'm just going to show you what we did there. This is the little test we just had running. I hope you recognize it. We go to the web shop and we log in with our super secure password. We sign in and we make sure that there's a welcome message. The most basic thing. Let me just blow that up a little maybe. Here we go. This is monitoring production at this stage. And what we're doing different here is the following. We run this from a bunch of different locations, in this case Ireland and Frankfurt. Well, we have a whole bunch of other ones if you want. And we run it every 15 minutes. Something fails. Then we send a message out to me, in this case. And we have a whole bunch of other alerting channels, as we call them. Might go to your ops team that is using PagerDuty or something else. And the rest is just Playwright. There's nothing different here. It is this piece of code, goes to production and does the thing. Cool, but this is just me copy-pasting something into some dude's web app. Okay, I get it. How can we do this a little bit neater? This is what we came up with. We're just going to open up this little extra project here. Again, let's go back here. There's the new web shop check again. Cool. I can run this right now. We just showed that. You're typing this in your IDE with the tools that you use. I could stick this in Git. Works perfectly well. What we came up with is, okay, let's take all those settings that you just saw, like it runs in these and these locations, needs to alert, needs to run every 15 minutes. Maybe if it fails, we do like a retry strategy, which you see here, and put that also in TypeScript in a normal class that you export in this case, or you don't even need to export it. We call that a browser check. This way we let you write Playwright code, and all the stuff that's specific for us lives in its own class. Pretty useful. What you also see here is that I actually have my little alert channel, which goes to me, and that's also just a TypeScript class. And we can just import that and say, like, okay, alert the email channel if this one breaks. We have a whole bunch of other ones here. You could put your PagerDuty here, your Slack. We have phone calls, and you can build a whole alerting structure there. Okay, cool. So now we have that. But how can I run that? We have a little CLI toolkit that comes with it. And we just do this. And I'm just going to add record flag. It's called npx checkly test. Checkly is just a command line. It's very similar to Playwright. We try to keep it very near to the same thing, but add stuff where we go into production monitoring, which Playwright doesn't do by itself. What just happened, I just ran it, right? It looks pretty familiar to what we just saw. But what actually happened is we wrapped up all this code, sent it off to our cloud, and we run it in US East. This makes sure that what you just wrote actually works on our runtime instead of just on your machine. We also just pooped out a little link here, which you can open up. And we just recorded a test session, what we call test sessions. And you'll see something very familiar here. Sorry, I'm just going to go back here. Yeah. Which means we just picked up that piece of Playwright code, ran it once. If that failed, we would not alert me because we're still testing, we're trying it out. And this is going to look familiar. Hey, we have the same time travel stuff. Okay, cool, that's nice. We have the same video, which is not terribly exciting right now. And we collect a whole bunch of other data that we can dive into. Again, this is the script that run, pure Playwright. So let's say we're super happy with this check. We built this. Okay, cool. What we would then do is deploy it. We would go to npx checkly and we do deploy. I'm going to add the force flag so I don't need to type in yes or no. And boom. What just happened is the following. I just updated this thing, this check in our UI, and you can actually see that we're tracking also all the Git information, updated less than 1 minute ago. That was me. The other one was prep. What just happened is we took the test and we made it a monitor. All the metadata that we configured is added. It's running now as you would expect. If this one breaks, you will get a message, right? And maybe wake up someone in your organization because this is targeting production. We have all the kind of things you might want to have there. We can allow you to store variables and secrets so you can target actually production systems with secrets like credentials or other stuff or keys that you might have. And this brings us kind of to the end of the talk also. Let's see, we're here. Demo, we did that. DevOps. So I was working in operations before we called it DevOps. We just called it Ops. And we were talking about the three problems, right? We have the tooling problem. Okay, Playwright's cool for that. Checkly also. Then we have the architectural problem where you need to recognize that testing is not production and there's some translation you need to do there and add some bits around it. But then the cultural problem is kind of interesting, right? And my kind of hot take here is that DevOps is a term that's kind of used for everything right now. It doesn't really matter anymore. But this is kind of the real DevOps in practice. Because what you're doing is you're solving an operational problem, uptime, availability of your production systems with development tools. You're writing code, you're storing it in Git, you're using your typical cycle. This is from an older talk I did where we said, hey, this is how this works. You write this, Mac is monitoring as code, do it locally in your IDE, you stick it in Git, you commit it, you push it on a branch, specifically so you can debug it locally, right? It's way better than in our web UI. Push the staging, oh, there might be a little typo in your test. Okay, let's fix it, another patch, boom, there you go. You get your buddy to review it, everyone's happy, and then you deploy it, in this case to our cloud. It could be anywhere else if you built that yourself. And now you're suddenly monitoring production 24/7, and there's alerts just on outages. It's really practical DevOps stuff. Short little notice, like these are some of our customers that we do this for. Some of these teams on this slide are doing this day in, day out. It's super cool to see. We're not a super, old company. We're 40 folks now. This picture we took 2 weeks ago, roughly 40 people, and we're working every day on this, trying to make that better.
All right, well, thank you very much, everyone.